Hello everyone, welcome to today's video on describing and performing rotations. So we're in this transformations unit, and we know transformations are when we have a change in the position, shape, or size of a figure. And then right now we're in the subunit of rigid transformations. So rigid transformations are those that keep the size and the shape of the figure the same. Really just the position and the orientation is changing. And another way of thinking about a rigid transformation is it's a transformation where the pre-image, the original figure, and the image, the new figure, are congruent. And that means they have the same side lengths and the same angles. All right, so we've already talked about translations and reflections, and today we're going to be talking about rotations. So the definition of a rotation, it's a transformation that turns a figure about a fixed point called the center of rotation. So we already talked about how a rotation is like a spin or a turn. Okay, so we see now we are taking our figure and we're spinning it or turning it around a fixed point, which we call the center of rotation. Fixed point means it is staying fixed, it is not changing, it is staying there the whole time. So we have the one point and then our shape is rotating around it. And we know that a point's distance from the center of rotation in the pre-image and the image is the same. So the distance from the center of rotation is the same, just like the distance from the line of reflection was the same for a reflection. But now instead of flipping it over a line, we're spinning it about a point. And then we have the angle of rotation. That's going to be important. That's the number of degrees that a figure is rotated. And it can either be turned clockwise or counterclockwise. Okay, so that is a useful thing to know if you're not sure about counterclockwise or clockwise. If you could try to imagine an analog clock, which aren't as common these days, that is how it defines it. So a clock goes like, if you're looking at the top, it goes like right and down, and then it loops around. That's clockwise. A counterclockwise is if you're looking at the top, it's going left and down. All right, and then we have these key concepts, these shortcuts we discovered in class together. So when we have a 90-degree counterclockwise rotation about the origin, about the point 0, 0, then we can use the transformation rule. XY becomes negative y, x. So in other words, the x and y coordinates swap, and then the original y coordinate becomes negative. When we have 180 degrees rotation, clockwise or counterclockwise, it's the same thing. The x and y's are staying the same, but they're swapping signs. And then when we have a 270 degree counterclockwise rotation, which is the same as a 90 degree clockwise rotation, xy becomes y negative x. All right, so now let's look at two examples. So first, we're going to be performing rotations. Performing rotations can honestly be a little tedious. It's a lot of work to do by hand if we don't have our shortcut rules memorized, but it's important to be able to understand what's going on generally, and then the shortcut rules can save some of the work for you. Okay, so in this case, we are asked, what are the coordinates of the image of trapezoid ABCD after a 180-degree rotation about the origin? So what we're going to do for all of these, we have our ABCD is drawn. First, we're going to locate our center of rotation. Our center of rotation is the origin. That's the point 0, 0. Okay? And now we know that we are rotating 180 degrees. They don't tell us clockwise or counterclockwise because going 180 degrees clockwise or counterclockwise actually puts us in the exact same situation because that's that straight line situation. It's halfway around, and half is the same thing in either direction. So what we're going to do now is we're going to take a point, one of the vertices on our pre-image, our original shape. So I'll start with D. Okay, here's D, and I'm going to draw a straight line that connects this vertice to my center of rotation, the origin. Okay, I drew that straight line, and now from that line, I need to make a 180-degree angle. We know 180 degrees, that is a straight angle or a straight line. And then we're also going to be dealing with 90-degree angles, right? That's like a corner, a right angle. Okay, so we don't really need a protractor if we are just dealing with 180 and 90-degree angles, which is going to be the case for us. Okay, so we'll go 180 degrees. That means we need to make a straight line, right? A straight angle, 180 degrees. In this case, I drew it in the clockwise direction, but I could have also drawn it in the counterclockwise direction like that. and we see we get the same thing. So we know that D is currently, well, what I would call like maybe one diagonal unit away from the origin, right? It's not actually 1 unit. When we're making that diagonal is a little bit longer. We'll actually talk about that later in the year. So what we could do is we could measure that distance with a ruler and see the length of it, and then go that same length along a 180-degree angle. Or if we don't have a ruler, we can still see it's that one diagonal, right? So it's like you're going the one up and the one right. So we need to stay along this 180-degree line. That's very important. But then go that like 1 and 1 distance. Okay, so when we go the 1 and 1 distance, we will get right here, which we probably could imagine, right? Originally, D is that 1 up, 1 right unit away from the origin. So I'm going to go like 1 down and 1 left from the origin in this case, because that's keeping it along my 180-degree line. We'll do the same thing with A. So here's A. I'm going to draw a straight line connecting my center to A. And then once I did that, I need to get a 180-degree angle with that line. Okay, so this is where I would have my protractor. I would attach my protractor. And I would say, oh, okay, that is 180 degrees, right? It's just going to be the straight line. So I can extend then, what is this angle going to look like? It would be along that line, okay? So I have that dotted line. That's my 180-degree angle with A. And now I need to go the same distance from the center to A, but now along this direction, spun around in the direction. So again, we could actually measure that length. Like we could take a ruler, measure how long this distance is. But if we don't have a ruler, there's kind of an easier way to do that. We can see that the general form is we're going up 1, 2, 3, and then we're going right 1. So it's like this 3, 1, and the diagonal that's formed from that 3, 1 distance. Okay, so here I'd go 1, 2, 3, left 1. I still have the 3, 1, and then that length now. This length is going to be the same as the original blue length that I just drew. And that's going to then get me to my new point. So this will be A prime. Okay, then we'll do it again for B. So I'm going to draw a straight line between the origin, my center of rotation, to B. And I need to get a 180-degree angle with that line, right? So I can imagine my protractor, right? 180 degrees is just going to be a straight angle. Okay, so it's going to be like if I continue this line. Okay, that would be the 180 degrees. So then the question is, B is going to be somewhere along that line, and we have to figure out where along that line. Well, if we had a ruler, we could measure this distance and then just take that distance from the origin along the line in the other direction, and we would end up at the right spot. Or we could use kind of like the directional distance. So I can see I'm going up 1, 2, 3 from my origin, and then right 1, 2, 3. So I'm going up 3 and right 3 to get B. So I have those like sides of 3 and 3. Okay, so I'm going to do the same situation here then. I'm going to go down 1, 2, 3, and then right 1, 2, 3, and I should get this point right there along the line. This would be my new B prime. Right, we can tell that that point with this line, it makes a 180-degree angle. So I know it is a rotation 180 degrees. And then the harder part there is just making sure we are going the right distance. It has to be the same distance that B is from the center of rotation, but rotated around 180 degrees. Okay, and then let me do C lastly. So I would draw again a straight line from the origin to C. I'm going to, in this case, it's like basically extending that line, because I need to make a 180-degree angle. C prime is going to be the same length of that current line segment that I just drew, the same distance from the origin as C, but it's now rotated 180 degrees. Okay, to get from the origin to C, I can tell that's going like, there's like 5 right and up 1. So I'm going to go 5 left and down 1, and that will put me right there. All right, and then lastly, I'm just going to connect the points, and I should see that I have the exact same shape, the same size. It has just been rotated about the origin. So this work it's very tedious. And if you're doing it on paper, there's like tracing paper you can use that would make it a little bit faster, where you only really need to move one point and then like trace the rest of it. Or really the easiest way in a situation like this is we use our shortcut. Okay, so this is where the important kind of shortcut rule we worked through in class comes in handy. We know that when we are rotating 180 degrees about the origin, we have the shortcut rule that xy goes to the opposite of x, comma, the opposite of y. So that means we are switching the signs of x and y. Okay, so originally D was the point 1, 1. D became this point -1, -1. A was originally the point 1, 3. So it becomes -1, -3. And we can check A. Yep, that's -1, -3. So we could have just done that. We could have just written the rules, what we know is supposed to happen and going to happen, and then connected them. So that would have been a lot faster, but then you wouldn't have gotten the idea of how we rotate. So these shortcuts are really helpful because that process was annoying and tedious. So it's a way to avoid that work. But if you just memorize the shortcuts and you haven't seen this, you don't have some sense of what's going on here, then you're not going to understand what a rotation is, and I don't want that either. All right, and then lastly, let's quickly just talk about describing a rotation. So here we have describe the rotations, the two rotations that map triangle NOP to triangle N'P'. Explain. All the work we're going to do together, we're going to assume that the center of rotation is the origin. Okay, so in that case, then we're going to draw a line from the center of rotation, our origin, to N, and then draw a line from our center of rotation to N's corresponding point, or N'. Okay, and then we see what angle is formed by these two line segments, right? The two line segments right here, they form a 90-degree angle or a right angle. So that's going to mean we have a 90-degree rotation. We're going to need the direction, and then it's going to be about the origin. Okay, so our question here, though, are we rotating it clockwise or counterclockwise? So we're starting at this shape, and we're going that way. That is like left and down? So that one's like left and down. Think, is that the way a clock goes? No, it's not. So that means this is counterclockwise. But now, see, they ask us for two rotations. So that's because there are two ways of describing this rotation. It could be a 90-degree rotation counterclockwise, or it could be some degree rotation clockwise. In the clockwise version, instead of thinking about this angle, that 90-degree angle that's formed, we're going to think about the other angle that's formed by those two line segments, which is this one. Okay, and that one is 270 degrees. We are going, in that case, this way, kind of right and down. That is clockwise. And we see it is 270 degrees. 270 plus 90 is equal to 360. Together they make a full 360-degree rotation. So either of those are correct since they're asking for both here. This is just saying these are the same thing. We could describe it as 90 degrees counterclockwise or 270 degrees clockwise. All right, everyone, that's all it is. It can be a little tedious, but I hope you're starting to get the sense of it. Okay, great job, everyone.